So in this video I want to talk to you about the periodic function. A periodic function is one that goes up and down forever and ever and ever and ever, both in the positive direction and in the negative direction. You're looking at a function here called y equals sine x, y equals sine x. Now to show you how y equals sine x comes about, let's take a look here. Here's our unit circle, so we're still working with a unit circle. Watch what happens as I move this around the circle. What's being created in that orange line here is a sine curve. That orange line is the same line as this line here, just on a different scale. Now, what's it constructed of? The x-axis here is equivalent to this angle. So at the moment, the orange dot is at 0, 0, because the angle is 0. As I move along, the angle is 90 degrees, which is also pi on 2. And you can see I'm at the top here, pi on 2. So the x-axis is the angle. Continuing along, 180 degrees, which is pi radians, 270 degrees, which is 3 pi on 2, 2 pi as we finish, 360 degrees. I can continue on forever and ever and ever. What will happen if I continue on forever and ever is it'll go up, down 360, up, down 720, up, down 1080, and we continue on and on forever and ever and ever and ever. So that's what the x-axis is. The x-axis is the angle. The y-axis, if you watch here, the y-axis is the height of this dot. So as we move along, height of the dot, and it comes back down again. The dot is on the x-axis, and then the dot comes down to -1. That comes down to here. And you should remember that sine theta is equal to the y value of this dot. Sine theta is equal to the y value of that dot. Now, similarly, here's our sine curve. We can also create a cosine curve that looks very, very similar. So as I rotate this, you'd notice the cosine curve starts at the top and comes down. The reason it's starting at the top is because it's not taking the height of this dot, rather it's taking the x value of this dot. So if you look at the x value of the dot at the moment, it's 1, and our green dot is at 1. If I move the dot around, the x value now is at 0, and you can see the green dot is at a height of 0. The x value moves around to -1, and you can see it's at the bottom of our curve here. X value moves down to 1 here, and then back to, -0 here, and then back to 1 here. So looking at a sine curve and a cosine curve side by side, you get this thing. They are identical curves. It's just that one curve has been shifted over a little bit, but they are both periodic functions. Let's look at it on our other graph so you can see what that looks like. All right, so here is our sine curve in green, and here is our cosine curve in orange. So it repeats, it repeats, it repeats, it repeats, it repeats. So let's talk about the amplitude first of all. So the amplitude is how big this curve is. So let's make it have a really big amplitude. Just going to look at the green line for now, not the orange line. So that's a big amplitude. Let's make it have a really small amplitude. That's a very small amplitude. Another way that periodic functions are used are in sound waves. Sound waves travel along like this. Loud noise, soft noise. Loud noise, soft noise. So the amplitude is equal to the highest value of our curve minus the lowest value divided by 2. So for example, the highest value here is 2. The lowest value is -2. So the amplitude is 2 minus -2, which is equal to 4. Divide that by 2, the amplitude is 2. So another way to look at that without getting into silly formulas, highest number, lowest number, find the distance between them. You can see the distance between them is 4, and then halve it, because we only want to know the distance from the highest point to the middle, or from the lowest point to the middle. That's what the amplitude is. So this is the amplitude. The distance between the highest and the lowest value is 8. So the amplitude is half of that, which is 4. Now, this doesn't matter. Periodic functions don't have to start from the origin. They don't have to follow the origin like this one is here. Let me show you a quick example. So it could look something a little more like this. I'm just going to move this. It could look like that. So the highest value here is 8. The lowest value here is 0. The difference between 8 and 0 is 8. So the amplitude is half of that, which is 4. Here, let's choose a different one. Okay, the highest value here is 7. The lowest value here is 1. The difference between them is 6. So the amplitude is 3. Alright, you'll notice here it says a equals -3. It doesn't matter whether the a value, we'll talk about a values later, it doesn't matter whether the a value is positive or negative, the amplitude is still going to be positive. Amplitude has an absolute value. Okay, so that's everything I know about amplitude and how to find it. Lastly, I want to talk about the period. So the period is the amount of time that one of these functions takes to repeat itself. Okay, so imagine for a moment that this function is like a roller coaster. Start here. We're in the middle of going upwards. Ching, 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 up, 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 up. Whee! Up, 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 up. You can see the repeat happens between here and here. The period of this particular function is from this point to this point, which happens to be 2 pi. The period from this point to this point is 5 pi on 2 minus pi on 2, 2 pi. The distance from, say, this point, 3 pi on 2, to negative pi on 2 is 2 pi. So the period of this function is the time it takes to repeat. It doesn't matter where I take my measurement from. I can take it from the scariest part of the roller coaster, the bit where I'm up the top. Start here, whee, and then we start again, whee. So that's the period. Think in terms of roller coaster. This is the point. When does that same point happen again? Mistake. The mistake people make is assuming that this is the same as this. And they say that the period of this function is from this point to this point. It's not. It's not that. That's a different part of the roller coaster to this. This is the part of the roller coaster where you're going really, really fast down. And this is the part of the roller coaster where you're going sort of chung, chung, chung up the hill. So they're not the same points. The distance for the period would be from here to here. And of course, periods can change. So could have a period that's much, much smaller, something like this. You can see our period here is just pi. So starting from here, going up, down, up, we end up here. Periods can lengthen, periods can shorten, but that's how you find the period. So, periodic functions, they come from the unit circle, they come in 2 different flavors, sine or cosine. The amplitude is the highest point minus the lowest point divided by 2, and the period is the time that it takes to repeat. That's all of it.